Welcome to this eDrilling webinar with the title Drilling Time is Money. My name is Morten Svendsen. I'm from eDrilling, and my co-host is Just Sverre Wessel from Maersk Training and Laurie Scott from Wintershall. Let's start with some practical information. You are all in this webinar in listening only mode. You can ask questions in this GoToWebinar interface, and we will try to answer all the questions in the end of the webinar. If we're not able to answer them before we leave, we will try to send an email with all the answers afterwards. When you are leaving the webinar, there will be launched a feedback form. We will hope you all can take your time to answer the questions. So the agenda for this webinar, we will start with a short look at the life cycle simulations. We will look at the Wintershall challenges and experience, the Maersk Training roles and responsibilities in this case, the integration, use and communication, the value added, and in the end, the questions and answers. So the life cycle simulations is the eDrilling way of looking at this, the way of simulating the wells. In the background of our technology is the physical models that we use to simulate the well, the hydraulics and the mechanical. The same models is used in different environments to allow for using in planning, in training, in real-time operations, and also in after-action reviews. So we are dividing it up in our planning phase, where we run what-if simulations, we do dynamic planning, and also post-well analysis. In the training, we use a drilling simulator with a topside drilling simulator connected to the downhole simulator, where we do team training, test new technology, produce verification, and we also have an advanced 3D visualization of the downhole. In the advanced monitoring service, which is the operation part, we use the models in a real-time environment with real-time data feed from the rig. We do forward-looking, what-if simulations, and we use it for decision support and diagnostics. And in this part, we also have the three-dimensional downhole visualization. And you see the tools that we have. We have the Well Planner, which is the planning tool. We have a WellSim Interact, which is a drilling simulator with an easy interactive topside interface. We have the WellSim, which is the bare bone in the WellSim Interact. We also have a WellSim Essentials, which is a more advanced topside simulator connected to the simulator. We have the Well-Ahead, which is the real-time decision support system. And we also have the WellVis and the WellVis 3D, which is the WellVis is the plotting tool, and the WellVis 3D is the downhole visualization tool. And we also have the Well Balance tool, which is the MPD set point generator system. So over to Laurie.
Yeah, I just want to try and give you a brief overview of what we saw as the main challenges up front, and a little bit of a taste of what actually happened during the operations. We share this rig in a consortium with Lundin and VNG, and it's a slot-based contract, so we don't really have a lot of control as to when we pick the rig up and start operations. But we got a bit unlucky here, and we picked up the rig just after Christmas time to take it to Haltenbanken in Norway, which To operate in Halton Bank in January, February, March, you're going to be dealing with a lot of weather. This is a floating rig, obviously. And this HPHT well, it had a lot of. It's a vertical HPHT well, but we committed to use all base mud in 17.5-inch section. We had long sections, we had heavy casing strings, and add that to the weather, and without the downhole risks, that's already a logistical challenge. We had some NPT, non-productive time, during the operation, but in the big picture that wasn't really a problem for us. We had a lot of good work before we started with the rig owner and all the various suppliers that we worked together with. And I think it's fair to say, apart from some noise, non-productive time with wear bushing and an MWD failure, we didn't really have any problems that caused us extra risk from a rig equipment point of view and from a downhole point of view. Specific sections, vertical 26-inch section, we recovered the mud to surface and used water-based mud during that section. Then we ran a very heavy casing, 20-inch casing string, which we foam cemented back to surface. That went very well. Next section was 17.5-inch section, and the biggest challenge we had there was to keep the mud weight as low as possible to give ourselves the biggest margins possible. We obviously have to do this responsibly and safely, and we used real-time pore pressure prediction together with the eDrilling software to help us understand what our operating window was and help us to make decisions there. But we also had a lot of weather during the 17.5-inch section. We had a disconnect, and we had over a week, I think it was 10 days actually, that we lost due to weather before we could run the casing after the section was drilled. Good decision to use all base mud in that 17.5-inch section and to keep the mud weight as low as possible. Gave us the best possible margins to do the cement job and to run the casing. 12.25 section, just below the shoe. Once you start, you go through the IMSA and the Quitnos formations, and we've seen in previous wells in the area that they're full of limestone beds, and they're weak zones. And as soon as you challenge them, you can't repair them. You just have you lose circulation, especially during the cement job. So we had a real focus throughout that section, drilling, running casing, cementing, to make sure that we maximised the window there. And again, we used the eDrilling software there to help us understand or make the most of the window, you put it that way. Running a 9/7/8 casing, both inside the 33/8 casing and in open hole, we had a real focus on running speeds. We didn't want to challenge, again, the IMSA and the Quitnos formations, and we did a good job there. Again, we used this eDrilling software to help us understand that up front, run what-if simulations, and to make that job a success. Then we started the reservoir section. We had a low case scenario and we had a high case scenario. The low case was basically hydrostatic reservoir pressure, and the high case was much higher. I think it was a 500 bar difference, if I remember. My memory is a bit faded because this happened some time ago, but it was a big difference. So we had some strategic decisions to make up front as to how we were going to deal with that. We didn't want to go in with the highest possible mud weight, because we would then be facing a big lost circulation problem. So we went in just a little bit under, if you like. All the rig crews would be trained up front in the simulator in this particular scenario, and we dealt with what we drilled into. Again, we used the software there to run what-if scenarios, but the software did not, of course it cannot predict what you have in front of you when it comes to reservoir pressure, so it wasn't something that we used there. But the biggest challenges that we had throughout this whole well is we're drilling in a mature area. There's lots and lots of wells, both normal pressure wells and HPHT wells. There's lots of history, and what we could see when we went through as much of the history as we could get our hands on was that we could see that a lot of the sections had been drilled with higher than needed mud densities, and people had perhaps put themselves in a corner by overestimating the formation pressures in all the sections. So we spent a lot of time doing pre-modelling, as everybody would do. We spent a lot of time modelling the pore pressure and fracture gradients and trying to understand what our operating windows were. And then during the drilling and casing and cementing operations, we tried to listen to what the well was telling us and make sure that we didn't go higher than we absolutely needed to go with our mud densities. And getting the real-time pore pressure and fracture gradient information that we were generating every day and presenting it and understanding it was a big challenge for us. And we made a smart decision just before we went into this operation to go into a partnership with eDrilling and use the software. And that was a very good decision. It made it much easier to run what-if scenarios, much easier to understand what we were actually seeing and make decisions. The biggest challenge, as I said, was the weather. We knew that for all the sections that we were going to be very close to the limits, even on a nice sunny day. And tried doing this in January, February, March, and we had to really be careful not to start anything that we couldn't finish. And that becomes you're managing a lot of stakeholders in this business, both internally and externally, and to make sure that we were able to, or we're trying to communicate to everybody all the time the risks of starting things we couldn't finish. So again, this information, the way it was presented from the eDrilling software helped us with that. Go to the next one. To cut a long story short, that we lost 37 days to weather. We lost almost 8 days to non-productive time, but we still managed to deliver this project on time and on budget, having drilled into the highest pressure that we could have found in this reservoir. So all in all, a good job. When we talk about specific experiences, lots and lots and lots of big and small things I can go through here, but I'm just trying to highlight what we saw as the biggest values with specific reference to this software that we used. And we saw up front that there was a lot of opportunity in the 17.5 inch section and the 12.25 section. If we could construct these sections and verify our barriers as we went, we would save a lot of time in the abandonment. Again, looking at the offsets, you can always pick what you want from offsets, but in a lot of these offsets, they've used up to 25% of their time just in the abandonment phase, because they have carried with them problems that needed to be dealt with during the abandonment. For example, in the 33/8, or once you've got the 33/8 in place, and if you can't verify the cement job, the risk that you're carrying there is you're going to have to re-drill the section. That's something we, of course, wanted to avoid. And in the 9/7/8 cement job, if we didn't manage to get the cement to where we needed it, we risked having to do a perf and wash job just to make sure that we had all our barriers in place there. But I'm repeating myself a bit here, but we were able to keep the the mud weight, especially in the 17.5 inch section, as low as we could, and that helped us greatly getting the cement job, having a successful cement job. Running speeds when we ran the 978 casing and the cement job there. So very useful. But the main thing for us the main expectation from us is eDrilling are producing a lot of simulations, they're producing a lot of numbers, and there can be a tendency that people just blindly produce numbers, put them on your desk, and they have no real ownership to what the numbers mean. And our expectation was that that they would understand what the objective was for each section, they would understand what our risks were, and when they presented any what-if scenarios, they would also detail to us what their understanding of the risks were. And this was very useful to us, because we were of course sitting having our own opinions on this, but when we have someone else who's taking ownership to what they're seeing and coming with their input that's thought through and quality checked, it gave us someone we could play ball with. And when you put a lot of heads together who are taking ownership to the job that they're doing, and you're able to have constructive and open dialogue with each other, it created a lot of value for us, because we were able to make good decisions based on good input that was coming from different. We were getting data from different avenues. This helped us a lot. It helped us to be able to react to what we were actually seeing, and that was our main intention when we started this. We weren't just going to blindly drill ahead based on pre-models. We were going to react to what we saw and make decisions based on what we saw. I think that's the main points I wanted to make, but just to highlight that when we actually drilled into the reservoir, this isn't a tool you can use to. It's not completely magic. We couldn't see the maximum pressure that we were going to drill into based on the simulations and the look-aheads. Yeah.
Okay, Just.
Hello. I'm going to be talking a little bit about the Maersk Training roles and responsibilities in this. And our main role was obviously to be a focal point between the operation and the model operators, since this was a remote location centre, and also to keep the dialogue with Laurie on a day-to-day basis. We also gave the operations to Laurie guidance and advice when needed, and we were the ball player with Laurie. So to speak, we gave them operational support whenever they needed it, or if they needed it. And we're talking about the eDrilling tools, and the interpretation of the model results, as Laurie's been picking on, is quite important. Because numbers in and numbers out, it gives you a bit of a defined answer, but sometimes you're going to have to evaluate that towards the experiences you've seen and how the actually well has been behaving. And that was a part of our job into this. We also had a lot of verification, because the model is depending on a lot of input data. Some of them come straight from the rig, and we don't do anything about the WITSML data which we're getting. But since the model is very sophisticated, we also had to make sure that the tallies were correct, that the pipe lengths and the BHAs, the mud weights and the rheology of the fluid, that everything was in line, and we also helped out to make sure that the next operation was planned ahead in time. And one of the things that Laurie also gave us was a bit of an empowerment to start researching and exploring the well boundary conditions. As I said, it was important for Wintershall to make sure that they understood the boundaries correctly. So our role into this was also to make sure that the pore pressures and the fracture gradients interpretations given were explored, and actually did a bit of a Q&A on them. We all know that the models are only as good as the associated interpretation, and the need of operational skilled people was a necessity in order to deliver a good product. Next slide will now show how we delivered on this. Our primary objective was to deliver an online risk register based on the Maersk experience, which was the previous well that Wintershall drilled, some of the other offset wells that were looked at, and the anticipated risks reviewing for the IMSA, which was the well to be drilled. This was continuously updated with the experience situations, like the losses, the cement jobs, running a hole close to the factory gradient in the Kvietnos and the NISA formation, which was quite weak. Keep track of the reported pore pressures on the factory gradients and include them into the risk registers. Gains, if that was experienced, was also included. So this gave Wintershall a three-dimensional picture on how actually the well had been doing. It gave them a three-dimensional picture on all the risks associated and the status of them. So I think that was our primary objective. The secondary objective was to use the e-planning tools, using their sophisticated hydraulic flow modelling to calculate the ECD, the ESD, and the combined hydraulic pressure distribution in the well. And when we take this back to the Nice and the Kvietnos formation, which was defined as a weak formations, we actually monitored them during any operations, and we put some ECD gauges onto them, which is a calculated one, but we calculate it based on the rheology that we get from the mud engineers and the hydraulic flow models and the pump speed and the rotations and the running speed if you're tripping. So the gauges we used actively during the 12 1/4 inch section. We used the dynamic calculations in order to assist in any well incident, like loss and gain scenarios, if that should be encountered. And we also plan to use some what-if simulations to be done in order to help the Wintershall. During 12 1/4, we experienced a bit of a shale, tight shale as well, and at some points we were looking at it and the pore pressure didn't behave as anticipated, and we had to run a few kick modelling in order to verify that we had a sufficient kick margin, both to get out of the hole and also that in case that we needed to wait for the weather, which was quite significant in this well. And also we would like to verify the modelability in HPHT drilling, and also that the concept was proven, was a part of the secondary objective. The tertiary objective for this well was to assist the Wintershall onshore and offshore team if needed. And one of the things that we did in order to make sure that Wintershall had all the relevant information was that we gave them a screen and a log on, and they were able to log on to actually view the 3D risk register continuously updated and continuously driven from the rig. So that was one of the good things. The other part was that some of this well risk in the two-dimensional and the planners, we used them in order to help Wintershall making the right decisions, or they could tell us what they wanted to look at and how they wanted to look at it. Obviously I am from the operations, and we like to also assist in a bit of a drilling best practice to help them do the right things the first time, rather than to do a reactive approach to things. So we suggested improvements on the drilling strategy, the operational strategy, and also the efficiency strategy in order to make sure that we deliver the well on time and within the budget. And lastly, it was also defined relevant learning points to be included into future projects. So we delivered 61 days on the well in total. We generated 44 daily reports. The mismatch between the 61 and the 44 is largely due to waiting on weather. We're piggybacking on 3,077 meters drilled. We generated 23 simulations in 14 different reports for the risk analyses ahead. We did a lot of kick simulations, total 5 in 2 different reports, and 3 what-if simulations, which was done ad hoc in 1 report. And this was largely due to the cement job, if I recorded correctly. The integration with the operation, and as Laurie has been talking a little bit about, was the importance of having it as a team. And we were obviously a part of the team, and we were given the Wintershall golden rule, you tell me, which emphasized a lot of that they put a lot of responsibility on us, but it also gave us a ownership in order to deliver a good product towards both Wintershall and to the well. We used the eDrilling tools in order to optimize the well delivery. The real-time monitoring and diagnosis was done with Wellhead, where we compare the sensor data and the simulated data, like ECD and the ECD management. And at some point during the well, the mud provider's calculations were a bit off by 2 points, if I recorded correctly, where we were actually talking about if we had to pull out due to that mismatch between the calculated DCD from the mud provider and the PWD sub. I think we ended up in a situation where we actually realized that the model that we provided were spot on with the PWD sub, and thereby we actually felt comfortable to carry on and to drill it to TD without pulling out. We did the real-time view in a 3-dimensional for understanding purposes, because there is a communication threshold between the onshore and the offshore team, where you want the offshore team to do something, but they need to buy into it if you want it done correctly. And the 3-dimensional tool was done, or was sketched, due to the fact that we wanted everyone to have a full understanding of the well and the associated risks and the experiences that has been going on. A well is not drilled in 2 days, so that means that there will be new crew coming on, there will be a new drilling supervisor, there will be a new tool pusher, there will be a new driller. So it was important that everyone had a full and the same picture of the history of the well. Every day we produced a 24-hour forecast with a well planner. The well planner is a tool, and in this case we were looking at we used the pore pressures and the fracture gradients given from the pore pressure prediction people, and we evaluated that as well at some point. But the main objective was to actually deliver a 24-hour forecast on how the drilling was going to be, with potential implications if there was any faults that you might encounter, and a few things like that. We updated the daily risk matrix every day, and in particular if you had any challenges or incidents or small hiccups along the road, we tried to include that into the risk register. And one thing is to drill down to TD, but the next one is to actually get out of the hole and go down with a casing and cement it in place. So we did a lot of simulating of the next operations in order to verify that they were able to do it, both to help them out with picking the right speeds, picking the right pump rates, and a few other things. The use and the communication. One of the things that we realized during this is that the Wintershall actually used our service proactively in order to make sure that they got the best quality data prior to making a decision. We were given a lot of empowerment in order to verify the boundary conditions, and we were also given a lot of empowerment to make sure that we were giving them the correct and the best answer or decision grounds. There was a really short communication line between the remote center and the Wintershall onshore, and there was effective discussions and a short route to make decisions. As I told, the Wintershall golden rule for communication was the you tell me philosophy, which generated an ownership, and we all had an overall common goal. And Wintershall optimized the use of the resources as well. So, for that, I'm going to leave the words again to you, Laurie.
Is this me?
That's you.
Just to try and sum up what we've been through. The biggest challenge that we've seen on both in normal wells and HPHT wells is there's lots and lots of information flying about. There's lots of different people involved, different service companies, and often a different understanding of what the actual risk for a project or a section, what the risks are. And some of the value that we got from this was we saw that we were able to put everything into a pot and present it in a very easy way so that all involved could understand what our decisions were being based on. We found it easier when we were projecting ahead to see what our actual limitations were going to be from a pore pressure and fracture gradient point of view. We did have real-time pore pressure prediction, and we did have in-house resources looking at this, but this eDrilling tool the outputs from it were easier to understand and interpret. It gave us when we've done this operation before, you mentioned the IMSA well, we spent, I think it was 6 days fixing problems during the P&A that were generated by losses in the Nysa and the Krytnos formations in 12 1/4. We were able to avoid that by not losing anything during drilling, casing running and cementing in the 12 1/4 section. This created a lot of value. That's an obviously measurable value creator. 6 days that we didn't lose during the P&A. No noise at all. And we had from the mud company, we had real-time, or we had people on board doing hydraulic simulations. We had real-time measurements from the downhole tools, but we also had a third tool that was able to help us make decisions when we saw any discrepancy between the modelling and the physical measurements. And sometimes when you're running an operation as a superintendent, I don't know how many superintendents are listening to this, but you can often end up in a situation where you're alone in the toilet trying to make decisions, and it was good to have someone to play ball with who really had understanding and ownership to what we were trying to deliver and what we were seeing. But I shouldn't have said that with Euston in the room, because he'll probably get... So, in summary, that was it. We were able to understand what we were seeing and make decisions based on it by just the clarity of the outputs and the quality of the outputs as well. Yeah.
So that was the last slide, and we would like to thank you all for listening in. We haven't received any questions in the question form, but if you have any questions, but we will be online for 5 more minutes if you have any questions. So again, thank you for listening in, and thank you Just and Laurie for helping me sorting these out.
No problem, Morten. My pleasure.